Okay, let's start. Hi, thanks for coming. This webinar is about the flaky tests, and everybody loves them, especially me. And we're going to talk about why we love them and why we don't really love them. We'll talk about, in the context, of course, of API tests, but what we're going to talk about today really applies to all kinds of tests, mostly automatic, but manuals as well. Didn't break any conflicts except for these guys. So that's me. I'm Gil. I'm a trainer and a consultant. And part of what I'm doing is work with people who wants to make software better, especially on the API tests and other stuff as well. Would be web testing, development, lots of AI in the recently, both working with and working against. So if you have any question, need any help, think about how you can take your team and upgrade them. Let me know and I can help them. That's me. Going to start with a little bit of a poll. So this is about flakiness. I'm assuming you've encountered it in some way. What is your biggest headache? Different environments, the fact that they do happen and that makes you think about the ones that do pass. Third one is about you fix one like whack-a-mole, fix one, something else pops up. And the last one is the actual time we're spending debugging those things. It's kind of annoying because a lot of the times you just don't reproduce, and then you try, and you say, well, wait for it to rear its ugly head again next time and see what happens. Okay, I'm going to end the poll here, and you know what's on top? Debugging. The time of debugging, which is not that interesting, really. It makes sense. It's like you come in the morning, you say, oh, I'm going to work on something failed in CI, and now you know how your morning's going to look like. We don't like that. So let me start talking about this. So, well, what happens when we have tests failing? Usually we don't look at it this way, but I do. So think about like a crime scene. Something happened, and now you look for what happens. Usually, in regular non-flaky environment, what will happen is that you look at the assert, you debug it a bit, you know what happened. But crime scenes for a flaky test is quite messy. And I want to know what happened here. So let me give you an example. Very simple example. I'm going to switch to code a bit. So this is going to be our examples today, like a book shop maybe, or book site for that. Yeah, you have books, you have orders, you have all kinds of things. And I'll jump into it later, and again, just going to show you an example of this. You have a test that creates a book. So yeah, you call the post to create the book with this. You have to get to see if it was entered correctly into the system. And this is a kind of a test that mostly works until it doesn't. Anybody want to guess? Put in the chat why would it fail at some point? The reason is that there's an assumption that you see this is a hint here. This is the clue. This is a unique ID. So when you try to create a new book with the same unique ID, and this unique ID exists in the system, it will fail. Now, why would it be there? That's the whole CSI part, the whole investigation. But when we run this regularly, there's probably some kind of cleanup that's being done that makes when running it makes it run it again, not bump into this problem. But some point somewhere, this cleanup may not be, or may not be automatic, or may not succeed for some reason. The idea will be there, and therefore the test will fail. Okay, so I'm going to go back into this and what you can do about this, but what's happening here? Why did it happen? I'm going to switch back to my slides before we jump back to the code again. So we have an idea in our mind about tests, which it's a good idea, really. We write test, and again, in my mind, it's an automated test that you have an assert in the end. Test should pass for the right reason. So we create a situation, some kind of state in our test, and we do an operation, we look at the result, and we look at that. The result should look like this. And when we say it should look like this, expect and assert something like that, that is the right reason for it to pass. When it is not, when the assert fails, we assume that it failed for the wrong reason. We expected to see 1, but it was 2. Therefore, there's a problem here. The right reason. The flakiness that we're talking about is really the wrong reason. Tests fail not because of maybe the assert failed, maybe it was something leading to the assert that failed, but it's not what we wanted to test to fail on. Mostly you'll see that because you run it again, you see, everything's okay, right? Nothing's wrong. It could be like hiding something behind it, but that's not a flakiness issue. That this is like maybe a test design issue. So why did this happen? And a lot of the time is really what happens here when we're writing tests, designing tests, automating tests. And we make assumptions. In the one that I just showed you, I assumed that when I run this test, there will be no unique ID in the system, and therefore everything will be okay. Why does that happen? Why do we think that this happened? There's a lot of what's happening in our mind when we're writing the test. I'm going to look at it in different angles, but I also want to remind you, which I don't need to remind you really, that today, not a lot of things happening in our mind, but somebody, let's call it Al, it will generate tests for us. And a lot of the things that we're going to talk about kind of derive maybe even more when we're using AI. So we're having an assumption in our head. It's not an explicit assumption, because if it was explicit, we'd say, we're thinking about this, maybe something else will happen, and it not the uniqueness, the index will already be there, and it might break our tests. So the assumptions that we're thinking in our head are usually implicit. We don't think about them, just like think through them. And when something breaks, it's because we didn't think about that is going to happen. And this is what I'm going to show you today. I'm going to show you all kinds of examples of what might happen, how to think about what led to this thinking, and what to do about it. Examples then, that we don't have like a Bible of what to do when. So where do we get all these kind of assumptions? Like I said, it's part of our thinking. We kind of do a model in our head. We want to check some kind of behavior. We're thinking about, well, this system needs to be in this state. And what happens really is that the system is not in this state. And then we get surprised and say, what happened here? And then we read logs because we don't understand and run it again. And again, we have some kind of model in our mind of what's really happening. And we may see it or we may not see it. So I'm going to go with you through a couple of suspects that cause flakiness. And like I said, I'm going to show examples in API tests. These things happen in web tests, mobile tests, even unit tests sometimes, integrated tests. I want you to think about what you're thinking, because this is the key here to solve this thing. So I'm going to switch back to my code. And like I said, this is what we call state pollution, right? This ran once, this created a book with this ID, so it sits here. And when we run it again, the state that we thought it would be is already there. We thought there won't be any unique ID, but now there is. So what do we do against these kind of things? So I'm going to show you examples. It's not like this is what you do always, but you can use a data factory. So a data factory is something that you write that in my case will create a new book ID every time. Therefore, it will be unique. How does it do it? In my case, it's going to be a random thing. But if I introduce randomness into uniqueness, I'm sort of getting rid of the problem. Now, it's not like the first thing I would do is write things like that. Again, I need to think about how I'm thinking. And I need to think like this is a problem here. This is a system that uses unique IDs. And therefore, I need to be careful about this field when I'm posting stuff. Now, this idea of I need to understand what's happening inside the system, this is the pattern that is going to repeat itself, because it's going to repeat itself. So that's the first one, state pollution. We need to understand what state may be left there before before our test runs. The next one is something that you probably, again, the first ones are going to be like something that you've probably been through. So not going to be two big examples. I'm going to move through them in terms of complexity. So this one is what happens when you run tests in order and everything is okay, but we run tests alone and they're not. Why is that? Well, this is, I chose very clear names for the test. So this one creates a book to delete. Guess what happens next? So I create the book. Great, check that it was created. It is indeed a temporary book. Then this one tries to delete the book, okay? And because I'm using the same ID, everything works when I run these two together. If I try to run it not together, or the second one before the first one, the book to delete will not be there unless there was state pollution, which happened when I last ran it. By the way, this is an example of how state pollution can happen. So if let's say, yes, for our sake, I'm creating the book and then I'm calling delete, and something happens here that fails. It doesn't delete the book for some reason. That means that when I'm going to run this again, it might fail. Okay, but we've passed state pollution. But keep that in mind, that state pollution can happen when it's not exactly that simple. It could be like I'm trying to delete something from a very big data structure, and I didn't delete it correctly, or the system did not delete it correctly, and therefore there's some junk in the system that will prevent me from running it again. Okay, so this is about obviously isolation. Why would this happen? Like this is like very simple. This is something that if I'd see there's something wrong here, that's not how you write a test. Like I said, if data is complex and you don't see all the details just in front of you, it is possible to see. It is possible to fail. Why would that happen? Well, this is where we kind of dig deeper in how we write and create tests. We usually, and this time I'm taking the human side, we'll do this one and then we'll do this one. So we're kind of creating some kind of sequence. And unless we know, there's a real dependency here, we won't try to fix it. This is very simple. We probably won't write it in the first place like this. And obviously, if you want to fix that, we're talking about isolation. So this one, the second part, will actually create its own books. You see different IDs. I might even use my data factory to create it to make sure that this one adds the book, this one creates a book and fails when it tries to delete. So isolate or try to wrap everything in a single context, let's go. Okay, no surprise there. I'm showing you very simple examples but they can get a lot more complex. I want you to think about something else though. When would this pattern appear? When will this dependency rear its ugly head? And the answer is, okay, I might run this alone, go back to the problematic ones. So I might run this alone, but we're going into a point in the next example that shows you that the way I run things on my computer are not automatically the way that they will run in CI or somewhere else's computer. So we need to be aware that how we run things here may not be the same as when they run there. And when they run there, they might also run differently every time. This is where flakiness comes. Okay, so let's step into the third one. Third one is about concurrency. And like I said, things are not running the same. When we're running in CI, a lot of the times run tests in parallel. Now, we don't see this as a problem when we look at this code, but let me walk you through this. So this one adds a review. So books have reviews. So there's a book, I'm getting a book. I know there's an assumption that the book is there. We passed that. So yeah, I'm getting the book, creating a review data, create a review for the book, and check that it was created. Okay, good test. The next one is completely different. This one checks the number of reviews increments correctly. So what happens is I'm getting the book. I'm reading the reviews numbers, how many reviews are for this book. I see I'm getting the reviews. And I'm creating another review, and I'm getting the number of reviews again, and there's a count after. And what I'm checking at the end is that count after equals count before plus 1, which is basic arithmetic, which should work. And when we run it alone, what could go wrong? Well, what can go wrong when I run it in a single manner? Nothing. What happens if these two run in parallel? Now, most of the time, nothing, unless at some point in time, this post happens between this line and this line. So when I'm taking a snapshot of how many reviews are there, if something happens during a system, during the run that increments twice the count, just because this one run in parallel, I will fail my test. I will see that I got incremented by 2. I will run it again. I won't see a problem because it doesn't run in the same in parallel. And it has to be very, very exact point where these two things happen. And of course, this is even simple to spot because I have two things in front of me. Things can happen on from different files in different times. And most of the time there won't be an overlap, but sometimes there's going to be an impact. So thinking, what can go wrong here? Well, I could ask what happens if something runs or changes the state between these two snapshots. If that happens, maybe I can do something about it. First of all, if I go into my mind, I'm going to look at different books, I may be working around the system, right? So if this one works for book one, this one for book two, this won't mix with this. And of course, this is like sort of a patch, right? You say, I know what's going to happen here, so I'm going to do this to make sure it doesn't happen. Yes, but this is what I want you to take. Like, we need to think about tests differently and not just write them, run them, see that they work and move on, but ask questions like, what can go wrong? What are we assuming that will not happen? And then ask, oh, but what if it does? Okay, so that was concurrency. Another thing that usually flakes is time, and in our case also locale. So here's an example. So this one, I have an API called orders, endpoint, sorry, where you can add something to the orders. You can order a book. Okay, so I check that and make sure that it was created and what was returned to me was the same ID. Actually, I got the ID in order to get. And when I do get, I actually need this in a couple of lines. I have also an endpoint called orders today. Orders today will bring you the orders from today. Okay, so and then this test makes sure that the order that I just created is in the orders of today, which will work most of the time, especially if you're working and the sun is out. When there might be a point in time, if it runs at night, where this part happens today and this part happens after midnight, which is no longer today, but today's tomorrow. So run it again. Everything's perfect. It looks okay. But then you need to see, well, you can probably read a couple of logs and see what's really happening here. At some point, you look at the actual time and see, something might have happened that created this weird behavior. Again, I need to think about what can happen. This is an example of time dependency, but it's not just time, it's about place. Because when I'm running tests, most of the time they're running on my machine or my machine and another server in another room or in another cloud that is close to me. We don't think about that the server might be somewhere else. And if it's somewhere else, it might behave differently, maybe configured differently. So this is an example of checking the today in a different way, in which it's by taking the time out of the string, the created that string that is in the database. And we are assuming that this is everybody's computer is going to be on the same format of time, which may or may not be, because your client may be on European some kind of format, and the server may serve it, save the data in a different way, US. So the assumption here is like everybody's working the same. And of course, you can, once you spot the problem, the assumption that, yeah, everybody's not working the same, you can do something about it. So you can look at the first test that we had, and instead of assuming that today is today, you actually look at the create date, save it, grab the actual date it was there, and look at the today and see what happens, and what you actually give the meaning of today for today. And the other one is like looking at the created date and looking maybe taking it to UTC, converting them both, and then you have the same time and the same format, and you can actually work with that. Two things about this. First of all, this doesn't assume much about the internal code of the API, although we kind of assume that the database works the same, right? Our code, though, the second one, it's a bit different because we kind of need to know that we need to convert. We don't know what happens over the server side, but we don't trust it, or we don't trust the developers or something. Let's convert everything to a single format which will work for us. So this works, not always, but kind of reduces the chances of blowing up. Next one. This is okay. So far, we kind of blamed ourselves, like we made assumptions, and we blame the developers because they make assumptions too, and we kind of follow them. It's time to blame somebody else, which is our DevOps people. They are also part of the party, and we kind of assume that they will work in the same way that we're thinking, which might get us in trouble because they might not. So this is a very simple example. This one gets the URL of the server from a file, which is somewhere here, and you get the books, call the endpoints, get the response to the test. Okay, and what is the server URL? So the server URL is in the file, and the file sits here. This is a Linux notation of something. So we kind of assume that the file sits here and runs on a Linux machine, which may be true, and which may be true sometimes, because they may run on a Windows machine as well. Now, and on a Windows machine, when you run this, this will fail because the config, it won't find the path. So this is like an assumption that the way we're running it here runs the same way everywhere. But this is like brings us to another point that we didn't think about, which is what is here? It's not the code, it's not our tests. It's a configuration, it's files that somebody puts somewhere, and it may not be us, or it may not be automatically put there. It may be put there automatically, but not as part of our script. Okay, so it may be not our deployment runs this, but somebody needs this for all the services out there. So there's a setup script that runs way before our tests begin and put the files there, and where there is might change. So we need to now, like we're kind of expanding of what we need to think about, suspect, blame. What other things do we need to control? So this is like the file, and of course, if I know there's going to be a problem, I identified the wrong assumption, is I'm going to write code a bit like that, maybe with a fallback of where to get into the information if it doesn't find it, a more safe code, and this kind of thing that kind of create the path both on Windows and on Linux the correct way, let's call it. But again, I need, in order for me to write this kind of code, I need to think about it in a different way that will work like that. Okay, couple more things. Third party. So we blamed ourselves, the developers, DevOps. Time to blame somebody else. And these are third parties. So we use third parties a lot. A lot of our code is not written because we're using somebody else's code, but a lot of the things that we do at runtime also calls other things. What are the third party? It could be third party completely outside the organization. It could be a third party of inside the organization, but somebody else's service. Somebody operates it, and we don't know this how it actually operates. We just know that it brings me answers, and most of the time it works until it doesn't. Okay, so here's an example. I'm going to show you for the third party. So this is a test. This one's not going to talk about. This is like health. Is it operating sort of like before? This one, test create order with payment. So you don't see it here, but when I'm calling orders, I'm ordering a book, and I'm checking that everything was created and looks okay. But inside the box, let me show you. I'm going deep into the code itself. So this is orders. You will see that when we're doing the post, so this is the post, what will happen is that it will call process payment. And process payment calls another payment service. This one, somebody else's service. We call it unreliable payment because it's mostly reliable, but it could be not reliable. Usually it doesn't come with a hint in the name. This is why it makes life so hard. So most of the time it does work. It is there, it answers. And you can see there's a lot of error handling here, which I expect it to be in part when developers put the code there. But if the third party is not reliable, we'll see that in our tests. Okay, so sometimes the test will fail because well, there's going to be an error. Now, we'll get the logs, we understand what will happen, but this kind of ruins our morning or maybe the afternoon, even the night. Now, let's get back to the test. Okay, because we're in charge in test, right? Okay, so the test looks quite innocent, really. I would write it with the assumption that the third-party service, Mr. Unreliable, will answer. And if you look at would the test fail for the right reason? Yes. Basically, the implementation, which is calling the third-party service, didn't work. We got the error back. So the test is not problematic, but it starts to create noise because we'll run it again and it will work, right? And we're going, that's the service. That's okay. It fails every time. And don't try it again. You don't even need to do this. Let's shape it with this one's red because we understand, or we think we understand how this one works. This is like a very bad way to go. There are different ways to do this, but again, what I want to do is not like point you at the solution, but the thinking here. What needs to happen for us to even take care of that? And the answer is we need to know how this thing works. It's not a black box. We obviously need to know that this happens because there's a service that misbehaves inside. Now, again, people who like to test black boxes wouldn't like this. But you see that as a thread that I went through all these things, it's a lot better if I know inside what happens inside it, so I can get ahead of it and maybe fix it. So how can I do this? A couple of things here. First of all, I created a fallback so I can actually, like before, if they don't find the server, go there. But this one does mocking. So instead of calling the service, I'm going to call, I'm going to intercept the mock and, sorry, I'm going to intercept the call and return something, and I'm checking that my code works. It's not the same as an integrated test, I know, but at least I'm checking that my code works, and if I run this in addition with that one, I can know what's happening. But look at the code. Okay, so this is the one that, this is the mocking call. When what it says here, when you call the payment service, just return this. We can return it to 100 and approve, like mock it. The thing is, another assumption that we do is this test solves a problem forever, right? We kind of mock the test, mock the service. Everything will be okay forever. Not completely, because you see, I'm using a specific, this is specific Python thing, but it could be like everything. So I'm using a response X, which is able to mock, where's my code? Orders, which is able to code to mock httpx.post. Now, let's say that in 3 days from now, the developers decide to use another library. Okay, Respix assumes, I assume when I'm using Respix, that the developer is going to use HTTPX library. Mocking will stop working if they did it. Now, this is not completely flaky, but it does show you that I need to know what's happening inside, because if I don't, the assumption of my code, my test is okay, may not be true tomorrow, 3 weeks from now, 3 months from now, 3 years from now. That's an inherent problem with mocking. It's not like a problem with us. But we need to know that whatever test that uses mocks is some kind of an assumption of how the code works. If the code changes, the test may stop working. Okay, so limitation of the tools. Okay, one final thing that I want to show you, and this is like a new guy, AI, and this is not about test generation. This is what happens that when your features use AI. So I have this new thing called books, the endpoint books, and I have, where is it? Where is it? This one, this is the regular create book. I also have a new one which is called books auto. A post that will get a title of the book, and it will go to the mighty LLM in the sky and ask it, oh, mighty LLM, who wrote this book? And it will get the answer, and it put it in the author field, and then I saved us something. Okay, so like an example. So let's test that, right? How does that look? Okay, so basically what we're doing is calling post author, and the example I came up with is a book that I find really boring, but is very useful. It's called Design Patterns. You might have heard or seen it somewhere. If you haven't, it's a very important book in software design. Very good, very sleepy if you get to actually read it. It's like a reference, but a cornerstone of software design. I recommend reading it at least once. half of it. Okay, so this is our title, the design partner. This is the full name of the book. And when I run it, I'm checking that the book was created. Okay, I'm calling auto. So that means that I'm expecting the LLM to call to answer, who wrote these things? So who wrote these things? Okay, so that is a problem because there are four people who actually wrote this book, and apart from their names, they're also known as the Gang of Four. So if you ask someone that the LLM who wrote design patterns, you might get different answers every time, which is a problem when you're using AI as a brains. The whole thing about deterministic results go away. So you might say, I'm going to look for Gang of Four. If it doesn't, probably something wrong, which is okay, but this doesn't work anymore. You understand that. How are you dealing with that? Well, first, I've done a whole webinar about this, about testing QI AI features. You can check that on the YouTube channel. And so the whole batch of techniques that we can use in order to do that, from asking AI to look at the result of the test and decide by itself, and golden data sets and scorecards, which I'm going to show you, for example. So what is a score? What does a score look at? Well, first we need to understand that we don't get exactly the same thing every time, but there are valid authors or names that we can get. So Eric Gamma and Blissines and Johnson, all kinds of things are acceptable, and then we can do like create book, validate semantic correctness, that what we actually get is it's one, at least one here, or you can even calculate a score that says, if you got these guys in, you get 10 points. You get Gang of 4, you got 50 points. You collect this, and if you have like more than a minimal value, then the test passes. It's a whole world of deterministic stuff, indeterministic stuff. Okay, going to go back to my slides. I'm not going to go back to my slides because I want to show you something else, which is a tool that I wrote because I said maybe something can help me identify these assumptions for me. So it's loading. And this took quite a while to develop. And this is like an AI tool. It's a prompt. You can run it. You can run it as an agent. And you see the couple of, I showed you 1 to 7. There's one more on the way. And how to analyze, what to look for. And some of it will be more deterministic than others. But if I ran this, I got this report. And for examples, if you look at the first test that I showed you, the state pollution one, it identifies the book ID. There's not the assumption that does not already exist in the system. The risk is high because it might break. On a second test run against the same server, the post returns a conflict of overwrites, so tells you what's going to happen. But also tells you that, there's going to be an assumption there that the server is running. When I tweaked with that, I said, okay, let's keep these things in, give it like a risk low because server is not running, everything will fail. I will probably know about it. So you can actually tweak that and you get a verdict. So this one works on at least those things. It's not complete. It doesn't find everything. Sometimes it exaggerates. But it's a tool that is interesting for me to use on my tests. And if you find this is going to be interesting for you, write me and tell me. And if you want to try it for yourself or something, let me know. Okay. So back to our things. This was the demo. And I want to like take a step from like the examples I showed you in like the bigger picture, because there is a bigger picture. First of all, a lot of us, like I said, are generating tests. We're not writing them anymore. Is this removing the risk of assumptions in our tests? The answer is no. There's a lot of assumptions in the test, but they're just not ours. We kind of inherit the assumptions of the test that the AI was trained on, okay? So kind of spreading the disease of assumptions. We need to know that it doesn't really go away. Second thing is what happens after that. So we already talked about test erosion or confidence erosion in our tests. So we see a lot of flakiness or some flakiness, and we started thinking, well, are these green tests are really green? Maybe they're not, and just something is hidden. The more tests we have and the more we see them working, and remember, this is not just tests that we generated. There's a lot of code that was generated inside it, and maybe the tests that were generated are not that's so good. That's the green mirage. But getting back to our topic today, if we generate more code, we're going to increase flakiness. Like AI amplifies everything, including flakiness. So that means we're going to spend more than Monday mornings on debugging this stuff. So that's one thing. A lot of the stuff is going to hit us more as we're going to use AI more. The second thing is even harsher because a lot of the code is generated automatically these days. And most of the time, that's a lot of code that is not being reviewed. Sometimes it's not verified. Sometimes it's not even measured if it's covered or not. So what happens is that you get like the knowledge void. I was talking about that as well in other videos and other webinars, is that in 3 years, 5 years time, you'll have a fewer people who actually know the system works because it's going to be fewer people because AI and a lot of stuff. And if you still have today enough people to ask around, say, well, how is it working? Why is it working like that? Why does the system behave like that in these cases? All you have is AI that will not have these answers for you, or maybe the wrong answers will have you chasing other stuff. So you don't want that. Tests are becoming a lot more than just tests. They're becoming the documentation of the system. It was always like that. It's just a lot more important right now as we're getting more and more tests and less code that's being known what it's actually doing. So we're moving forward. We're already moving forward into the era of we need to take control of our tests a lot more than we did because they serve a higher purpose than they just automation. It becomes a lot more like documentation. So the stakes are a lot bigger. So what can you do? There are a couple of things that you can do. First, change how you think. Very easy. Start asking the question. So first of all, if you're working alone, writing tests for yourselves, every time stop and think, well, what can go wrong here? What am I missing? What will break this test? Look at the code underneath. Understand how the system looks at state, how it keeps state, what makes state change. Understand how CI works. What runs in parallel? What can run in parallel? What runs where and what time? If you're working with somebody, like I worked with the Genie, but if you actually have someone to work with, have them ask you, well, what's wrong here? Or maybe use my tool to identify what am I assuming that will always work but may not. And when you start thinking like that, getting a lot more suspicious, you start to fortify your tests. Your tests will become less susceptible to this kind of assumptions and misstate management. So what can you do? Like I said, think differently. If you want to know more, I have 2 master classes coming. The first one is the tactician. It's for testers in the field. A lot more techniques about debugging, removing flakiness, designing tests that are stable, testability, all kinds of stuff. You can go there, join the waitlist, and wait for me to tell you, this is coming. So it's a whole masterclass with me live, few sessions with homework and a project. Second one is the masterclass, the strategist, which is for people who are think a bit more strategically. It's not like they are better than the tacticians. But if you look at how is my organization doing today, how are we dealing with all the things that AI is going to throw at us, costs of token, all kinds of things of test design, test planning, how to deal with so much code being generated, and we're still 3 people in the QA team. This is for the strategist. Again, if you're interested in stuff like that, go to this waitlist. I will let you know when things are opening up. And if you have any question about these things, write me, gil@testingguild.com. And this is the point where I'm actually going to say thank you. Okay, so thank you again for coming, and thank you for listening, and I hope this was valuable for you. If you're interested in one of the million things that I'm doing, get in touch with me. There's the master classes, there's other courses that I do, consulting, and if you're interested in that prompt I have for my assumption monitor, let me know. Okay, so thank you very much, and I'll see you next time. Bye-bye.